Okay, I think let's get started. I think we gave everybody enough time, and I'm really happy to be back at Hackcon after some years of not being here. And so I'm really happy to see all of you. And if you have some kind of questions, let me know. Let's get started. So, how to crash a hackathon like an airplane? What a strange title. Hi, I'm Daniel, a particle physicist and hackathon organizer at GluonNet, the University of Lancaster, the port at CERN, Geneva, Switzerland. I need to start with a disclaimer. I don't crash airplanes professionally. It's a more personal passion. It's more this personal passion to analyze airplane and other complex system accidents, their reports and investigations. I think it's even our society's duty in respect to the victims and their families to best learn from these tragedies. While being this personal passion, it dramatically helps me in succeeding professionally. And at the end of the workshop, I hope you sure will understand how it will help you to organize better hackathons. As a particle physicist at CERN, I was managing teams of up to 24 scientists from all over the world operating the Atlas experiment of a Large Headron Collider. In our airplane analogy, we have been constructing together with 3,000 engineers a completely new type of airplane. And with 24 pilots, we have been test flying it together for the very first times. An incredible learning. As a hackathon organizer, I helped to create over 30 different unique hackathon experiences. Maybe the best known is the port at CERN. And the latest, I was co-organizing with a team from 160 different organizations as the Versus Virus Hackathon. Most strikingly is that from the idea to realization, it was less than 2 weeks. 4,500 hackers participated, 500 mentors, including the president of the Swiss parliament and 24 members of the parliament, 2 government ministers. From 500 proposals, we created 190 challenges, 600 teams formed, created then 263 projects. We distributed $250,000 in seed funding, and additionally to that, an incubation and support program of double that value. One project led to a change of the Swiss law allowing digital parliament sessions, Pandemia Parliament, for the current crisis. As a co-founder of GluonNet, we analyze global aviation big data to reduce the environment impact, improve safety, increase capacity, and reduce cost. Today, I would like to tell you about 3 aircraft incidents. The question that I will ask you at the end is, what do we have in common? What is the striking commonality between these 3 very different events? The 19th of July 1989 was a perfect day to fly from Denver to Chicago. Perfect flight weather. You would have boarded this McDonnell Douglas DC-10 Series 10 with a call sign November 1819 uniform. From today's perspective, you would have found something very strange. 3 engines, 1 on the tail. Pilots loved this airplane. The Cadillac Fleetwood of the skies. As with the 3 engine, it was extremely powerful at takeoff. The pilots put their hands on the throttle and it slammed you back into the seat. It was considered to be extremely safe due to the triple redundancy engines, and it was comfortable and quiet. With 18 years in service, it was a mid-age airplane. Typically, they are operated until they're about 30 years old. About 1 hour and 7 minutes into your flight, you would have finished your meal. Still, you would have smelled the chicken strips they served, and you would have suddenly heard an incredible explosion at the back of the airplane. You would have thought of a bomb. So, you would have been smashed into your seat, while the airplane immediately inclined and climbed 300 feet. For sure, you would have spilled your tomato juice. You would have seen the flight attendants directly grabbing the next armrest, diving to the ground, trying to avoid being sucked out of the airplane in case it was an explosive decompression. But nothing happened. It was not a bomb, It was not an explosive decompression. If you would have been in the cockpit, you might have seen 57-year-old Captain Alfred C. Haynes, 49-year-old co-pilot First Officer Robert V. Records, and 51-year-old flight engineer Dudley G. Dvorak, first given a brief look to where it moved. No explosive decompression. With 30, 20, and 15,000 hours of flight experience, and out of the 7,633 hours on the DC-10, they were all more than reasonably experienced. First Officer Bob Records immediately grabbed the yoke, switched off the autopilot and shouted, "I've got it." Flight engineer Dvorak immediately sees that the gauge of that engine 2 failed. So following as standard operation procedures, he radios the air traffic control to request to descend to a lower flight level. A single engine loss is not an emergency on a DC-1010. It's not a big deal. Captain Haynes asked flight engineer Dvorak to read out the engine shutdown checklist. First point, reduce the throttle to idle. The lever won't move. Second point, cut the fuel supply. He tries, it won't move. Latest here, it was clear that this is not just an engine failure, not an engine flame out, not an engine shutdown. It is something serious. He knows that because a DC-10, all its controls are physical connections, steel cables. First Officer Bob Records seeks the attention of his captain. "Al, I can't control the plane." We don't know the exact words, as the cockpit voice recorder was on a 30-minute loop. So the first 14 minutes after the explosion are not recorded. Captain Haynes looks over and sees that Bob has turned the yoke all to the left and pulled back all the way, something that you wouldn't never do while at cruise speed. Still, the airplane goes in the opposite direction, right and down. He takes the yoke, tries to control the airplane, no effect. In the meantime, flight engineer Dvorak studies what is happening. He realizes suddenly that the horizon is tilted. The airplane is banking by over 35 degrees, way more than what one normally would use for a commercial airplane turn. He shouts, "We are rolling." Captain Haynes reaches down, closes the throttle of engine 1, sets the throttle of engine 3 to full, and with that symmetric power, slowly rolls back the airplane into level. Simulations later will show that if he would have reacted in any other way or a few seconds later, the airplane would have rolled over into a constant, irrevocable straight descent. They saved the airplane in that moment. Dudley Dvorak addresses the passengers over the PA system to tell them that they lost the tail engine, that the airplane can fly fine with 2 engines, and that they will descend and continue to Chicago with a small delay. Just seconds later, Dudley realizes what he was searching all the time on these hundreds of gauges. He sees that they have no hydraulic pressure and no hydraulic fluid in any of the 3 hydraulic systems. He now understands that the airplane is not controllable. First Officer Rickard now declares emergency to air traffic control and asks them for a nearest suitable airport. They are sent to CX City. They call Head Flight Attendant Jen Brown to the flight deck. She's the second on the left with a turquoise jacket, together with her fellow flight attendants of Flight 232. After the loud explosion and the heavy banking of the airplane, she knows immediately that being called to the flight deck at this moment of the flight is not a good sign. In her memory, she tells that her entire world changed when the cockpit door opened. No panic, but the sense of crisis was immediately evident. They tell her that they have no hydraulic pressure. They can control the airplane and that she should prepare for evacuation in about 30 minutes. Captain Haynes asks his flight engineer Dudley to read out the procedure to handle a complete hydraulic loss. There is none. The possibility that all 3 redundant hydraulic systems would fail at once was rated so low that there was no procedure. They decided that Dudley radios United Airlines maintenance, while Captain L makes the initial contact to Sioux City Tower and talks to Kevin Bachman.
Okay, so you know we have almost no controllability. Very little elevator and almost no aileron. We're controlling the turns by power. I don't think we can turn right, but I think we can only make left turns. Well, we're starting a little bit of a left turn right now. I mean, we can only turn right. We can't turn left.
United 232 Heavy, understand, sir. You can only make right turns?
That's affirmative.
In order to understand Kevin Bachman's calm but surprised reaction, the message he got was there is an airplane heading towards his airport that can't control its ascent or descent, nor its roll, and the only way to control the direction is to turn right by controlling the engines, and not as usual by rolling the airplane with the ailerons on the wings. He needs a second to digest that. In the middle of the message, the cockpit voice recorder is starting, so we know also the exact words they spoke in the cockpits from this point. At about the same time, Jane Brown has briefed her first-class flight attendant, Virginia Jan Murray, with a pink top, who returns to first-class section. Danny Fitch sees her distressed, gets her attention and pulls her aside. They talked before on the flight, so she says, "Jan, don't worry about this. This thing flies just fine on 2 engines." She leans in and whispers, "Oh no, Danny. The captain told us we lost all our hydraulics." She tells him that because she knows that Danny Fitch is also a DC-10 pilot in civilian dress commuting to Chicago. But Danny Fitch is not only a DC-10 pilot, he's a DC-10 check pilot, spending most of his time in full motion flight simulators, preparing other pilots for the impossible by guiding them through all possible emergency scenarios. So he immediately knows that Jen must be wrong, as the DC-10 has a triple redundant hydraulic system, 3 systems, completely separated and isolated from each other, and only one is enough to control the airplane. Each of the flight control surfaces is controllable by at least 2 of the systems. The reason for that is that the DC-10 belongs to the first generation of airplanes that has no manual reversion. This means that the air control surfaces that you see in red are just too big and have so much forces acting on them that if hydraulic fails, you anyhow can't wrestle them by human force. So Danny has never taken anybody through a scenario of a full hydraulic loss because there was no need for that. What Czech pilot Danny Fitch didn't know, and nobody knew at this time, was that the fan rotor disc of the front of a tail engine had failed in an uncontained way. The failure was caused by a microscopic defect enclosed during production, the so-called hard alpha inclusion. It was in the titanium alloy rotor, and it caused growing cracks over time that stayed undetected in inspections. You see this red little arrow on the left picture. The fan blades were breaking into over 70 sharp fragments, touring gashes into the aircraft tail stabilizers. On the right, you see the reconstructed blade trajectories that pierced the stabilizer. And here, and only here, the tail stabilizer sections, the 3 hydraulic systems are close to each other. You see them here in black, blue, and red. The fan blade fragmented severed the first and third systems' hydraulic lines. Parts of the first and second hydraulic system were ripped off with the initial explosion. That forced a loss of all pressure and quick loss of all hydraulic fluid in all 3 systems. Within 2 minutes, all hydraulic fluid had completely drained from the lines. A photo taken a few seconds before the airplane crashed shows also the damages. The photo quality is not too good, but the light shining through big holes in the stabilizer speaks a very clear language. Not knowing all this, but knowing that Jan must be wrong, then he asks Jan to let Captain Hayes know that he has a DC-10 training Czech airman on board, and if there's anything that he needs to do, assist, he would be happy to do so. Captain L is hoping that maybe the Czech airman has a procedure not in the books and welcomes him to the cockpit. There are 3 parallel conversations, so let's see if you can read along. Captain Hayes says, "My name is Al Haynes." "Hi, Al. Danny Fitch." How do you do that? How do you do, Danny?
Oh shit, no, that was again. Hey,
well, we'll have a beer record all night. Well, I don't drink, but I'll sure you have one. So I turn you. Well, actually, don't.
Captain Hayes continues. Can't think of anything that we haven't done. There really isn't a procedure for this. And Danny Fitch confirms, no. Both agree. There's no procedure. But nobody had survived the loss of flight controls in the last 25 years. Danny Fitch had learned about the 1985 crash of Japan Airlines 123 caused by catastrophic loss of hydraulic control and had wondered if it was possible to control an aircraft using throttles only. He had practiced under similar conditions on the simulator. So he squats between them and controlled both engine throttles at the same time. Here's a radar track. The plane enters the radar track at the bottom blue arrow and then fails at the top red triangle. And Danny Fitch takes over the throttles at the middle pink airplane. They manage to reduce the descent of the airplane, but they have not too much luck going straight. So doubting that they can make it to the airport, they call the head flight attendant Jen Brown back to the cockpit.
And we're going to try and put it into Sioux City, Iowa.
Yeah.
It's going to be tough. It's going to be rough.
We're going to evacuate, sure.
We are. Well, we're going to have the gear down.
Yeah.
And if we can keep the airplane on the ground and stop standing up, give it a second or two before you back up. We're down 1,500. Roll back a little more. The brakes will be the signal. It'll be over the PA system. Brake, brake, brake. And then if we have to evacuate, you'll get the command signal to evacuate, but I really have my doubts to be standing up, buddy. Good luck, sweetheart. Okay.
A very transparent, honest, and direct communication. Jen Brown goes back and instructs her fellow flight attendants. In the meantime, there's some excitement in the cockpit, as after 2 full right circles, they finally manage to turn left. Here at the top, middle pink airplane.
Okay, United 232, we're starting a left turn back to the airport. Since we have no hydraulics, braking is going to really be a problem. I would suggest the equipment be towards the far end of the runway. And I think under the circumstances, regardless of the condition of the airplane when we stop, we're going to evacuate. So you might notify the ground crew equipment that we're going to do that.
United 232 Heavy, Wilco, CERN. If you can continue that left turn to about a 220 heading, sir, that'll take you right to the airport. United 232 Heavy, you're going to have to widen out just slightly to your left, sir, to make the turn to final, and also that'll take you away from the city.
Whatever you do, keep us away from the city.
Keep us away from the city. We were all but optimistic. After finally some success to fly straight and to align with the airport, you can hear the relief when they have the airport in sight.
United 232 Heavy, roger. And advise when you get the airport in sight.
Got the runway in sight. We'll be with you very shortly. Thanks a lot for your help.
United 232 Heavy, the wind's currently 360 at 11, 360 at 11. You're cleared to land on any runway.
You want to be particular and make it a runway, huh?
With all that stress, Captain Hayes cracks a joke with air traffic control. They are well aligned on the runway, but they are waiting. With no hydraulics for the slats and flaps, they can't bleed off speed. They were traveling with about 250 miles an hour. A normal DC-10's landing is about 125, so they are double speed. And the sink rate, 3 times of a maximum specified sink rate, 6 times of a normal landing. I will show you a video of a crash. There's a lot of fire and smoke, so you might not want to watch. They almost did it. But Captain Haynes later said that their luck ran out 50 feet above the runway. The right wing dips, hits the runway, The plane cartwheels and catches fire. Of 296 people on board, 185 survived.
More than that to the people he saved.
There is no hero. They're just a group of 4 people who did their job.
The NTSB put 40 different flight crews into the simulators, replaying the same flight conditions. A very few of them came even as close to the airport as the UA-232 crew. None of them managed a better landing than the original crew. The next 2 incidents I will describe you in much less detail, even though that they are similar complex as the UA-232 incident, but the striking commonality can also be spotted in the short descriptions. The second incident you might even remember, it's Air France 447. It was scheduled from Rio de Janeiro to Paris on the 1st June 2009 on the Airbus Air 330. 203. 58-year-old Captain Marc Dubois, 37-year-old First Officer David Robert, and 32-year-old First Officer Pierre-Cédric Bonin were taking turns on this long flight. About 3 hours and 40 minutes in the flight, they entered an area of storm and turbulences. Likely the 3 aircraft's pitot tubes, which are measuring the speed, got obstructed by ice crystals, which created temporary inconsistencies between the airspeed measurements and disengaged the autopilot. And 3 seconds later, the auto thrust system disengaged. Captain Dubois was taking a rest. First Officer Co-Pilot Bonin was in control. He was worried that they overspeed. He tried to correct the roll to the right by deflecting his side stick to the left, but overcorrected, and he was fighting for next 30 seconds the aircraft rolling alternatively left and right. He abruptly pulled back on his side stick, raising the nose, causing an aerodynamic stall. They called the captain back to the cockpit.
On a pourtant les moteurs, qu'est-ce qui se passe, bordel? Tu comprends ce qui se passe ou pas? J'ai plus le contrôle de l'avion. J'ai plus du tout le contrôle de l'avion. Merde. C'est quoi là? Je crois qu'on va trop vite.
Just under a minute after he was first called, Captain Dubois returns to the cockpit, taking the jump seat behind the younger officers.
Bon, qu'est-ce qui se passe là? Qu'est-ce que vous foutez? Mais qu'est-ce qui se passe? Qu'est-ce qui se passe? Je sais pas ce qui se passe. Vers le contrôle de l'avion. On a totalement perdu le contrôle de l'avion. On comprend rien. On a tout tenté. Alors tiens, prends ça. Prends ça. Le problème, c'est que j'ai plus de l'avion. D'accord.
The variometer, the instrument that measures the vertical speed of the aircraft, has stopped working.
J'ai plus rien qui s'affiche. On n'a pas une seule indication valide.
Because Bonin is still pulling the stick back, the nose is up and the plane is stalling.
Je crois qu'on va à une vitesse de fou là. Qu'est-ce que vous en pensez?
He thinks the plane is going too fast and moves to put on the air brakes.
Soon after co-pilot Robert said, "Climb, climb, climb." Bonin replied, "But I've been at maximum nose up for a while." Now, finally, Captain Dubois realizes that Bonin was causing the stall and shouted, "No, no, no, no. No, no, no." They couldn't recover from the aerodynamic stall. And only a few seconds later, Air France 447 was eventually crashing into the Atlantic Ocean, killing all 228 passengers and crew. The aircraft's flight recorder were not recovered from the ocean floor until May 2011, nearly 2 years later. The third incident is Qantas Flight 32 from London to Sydney via Singapore on the 4th November 2010. The Airbus A380 suffered an uncontained failure in one of its 4 Trent 900 engines. The failure occurred 4 minutes after takeoff from Singapore Changi Airport over Batam Island, Indonesia. Here is Captain Richard Champion de Crispigny with his 35 years of flight experience about what happened.
Because I say, if you haven't flown on a 380, which is actually totally inappropriate today, but I say it's smooth, it's comfortable, it's powerful, and most importantly, it is so amazingly quiet. 4 minutes after takeoff, 2 explosions. Is that one engine failing twice, or is it 2 engines failing? I don't care. It doesn't matter. I press the altitude hold that makes the nose come down to level and should ease the thrust on the engine, so it should stabilize. I check we're above the safety height. We're not going to crash into the mountains. Then I press the heading hold button. That stops the aircraft following a curved departure, locks our trajectory, and now we're in a straight path. And then I look, mind you, at the time the alarms are going off, the top screen's covered in red lights, the checklists are erupting on the screens in front. No one's saying a word except me. And then I look at the speed. The speed's increasing. We're about to overspeed the aircraft. No time to think about it. I grab the thrust levers, rip them back. I say to the pilots, we're at constant altitude, constant heading, constant airspeed. We're above the mountains. We are safe. ECAM actions. Was that a bit distracting? Because that's what it's like. That alarm went off about 125 times during the flight. Very distracting. You have to keep your focus. We didn't race into a checklist. If you race into a checklist before you've checked the aircraft is flying, you may not even get to finish the first checklist before you crash. The aviation rule for pilots is aviate, navigate, communicate. Rule number 1, and that's what we did. It took about a minute. Interesting.
When the engine disintegrated, it caused extensive damage to the nacelle, so which is where the engine is mounted, the wing, fuel system, landing gear, flight controls, engine controls, and a fire in a fuel tank that self-extinguished. The subsequent investigation concluded that the failure had been caused by a breaking of a stub oil pipe which had been manufactured improperly. The crew was holding for almost 2 hours to assess the situation when the aircraft made a successful emergency landing at Changi. There were no injuries to the passengers, crew, or people on the ground, despite debris from the aircraft falling onto houses in Batam. No, over to you. Grab your yoke, take control, and think, what are the commonalities between these 3 very different events? You have 2 minutes individually before we will discuss all together. So as the causes of the incident sound like they were out of the pilot's control. That's a nice point. Aviate, navigate, communicate. How calm the pilots were, yes. One thing I see that you don't see my slides anymore, right? There seems to be something wrong. I'm trying to fix that. Give me a second. Do you see my slides again? So can you write in the chat if you see my slides? Perfect, okay. Okay, so how calm the pilots were is one common thing. Yes. Any other ideas? Because the result of the 3 incidents is quite different, right? We have one which is quite dramatic. We have one that basically, ended perfectly. The other one is somewhere in between. There's a point that pilots weren't completely fault of the crashes, maybe. Okay, let me tell you a little bit of what commonalities are. I think you identified some of them. But I think one of the main commonalities between all the 3 incidents is that the human interaction in the cockpit decided about the fate of the airplane. The flight crew is the most important factor. They can turn a tiny system failure through a series of cascading events into a catastrophic disaster, or they can turn a catastrophic system failure in an impossible way to the minimal possible damage. Let me tell you about CRM, Crew Resource Management. In the late 70s, a series of airplane crashes led to investigations, and the results of it was devastating. About 70% of the accidents were caused by human errors. And in most cases, the crew even knew the solution among them. The latest of these incidents was marking the start of CRM, Crew Resource Management. It was United Airlines 173. On the 28th of December 1978, 52-year-old Captain Melbourne McBroom, with 27,000 hours of flight experience, with 5.5 thousand hours experience on a DC-8, was flying a DC-8, the United Airlines 173, from New York to Portland. During approach, the right gear fell free due to a corroded retract cylinder, a loud noise, and the gear was correctly locked. But the micro switch broke from the fall, making the crew believe the opposite, so that the gear was not locked. They aborted the approach and flew a 1-hour holding pattern and crashed due to fuel starvation. A perfectly flying airplane. And stunning is that the other members of the crew tried to make the captain aware of the fuel issues at least 3 times. The NTSB concluded that the airplane crashed due to poor collective situational awareness, failures in the team communication, misunderstandings. They crashed in wooded, populated area of suburban Portland. 8 passengers, 2 crew members, including the flight engineer, died. 170 people survived. This led United to establish Crew Resource Management. So CRM is designed for high-performance teams. So high-performance teams are composed of individuals with proven skills and knowledge to handle difficult and complex scenarios. They suffer from communication failures as any other group. And high-performance teams are often involving strong personalities and are often difficult to lead. The primary goal of Crew Resource Management is enhanced situational awareness, self-awareness, leadership, assertiveness, decision-making, flexibility, adaptability, event and mission analysis, and most importantly, communication. Specifically, CRM aims to foster a climate or culture where authority may be respectfully questioned. This is because cockpit voice recordings of various air disasters reveal first officers and flight engineers attempting to bring critical information to the captain's attention in an indirect and ineffective way. By the time the captain understood what was being said, it was too late to avert the disaster. If you become a pilot today, or you lead high-performance teams, you'll learn in many months about the best CRM methods. So all attempts to summarize, it's naturally insufficient. So only so much for now. If you lead a team in which everybody's voice can be heard respectfully, you already achieved a lot. And one of the best summaries I heard is from somebody who has used it perfectly in a real situation, Captain Al Haynes.
The preparation that paid off for the crew was something that United Airlines started in 1980 called Cockpit Resource Management. Up until 1980, we kind of worked on the concept that the captain was the authority of the aircraft. Whatever.
Can you confirm that you hear it?
Yeah, we've lost a few airplanes because of that.
Perfect, okay.
We had 103 years of flying experience up there in the cockpit, trying to get that airplane on the ground. Not 1 minute of which we had actually practiced, any one of us. So why would I know more about getting that airplane on the ground under those conditions than the other 3? So if I had not used CLR, if we had not let everybody put their input in, it's essentially we wouldn't have made it.
So you might ask yourself, what has this to do with hackathons? So I give it back to you. Huh? What is the worst possible scenario you can imagine happening at your hackathon? What is the biggest fault? I give you again 2 minutes and then we discuss a little bit. Power outage, yes. No one shows up. No one shows up can be different. It can be different things. It can be no volunteer show up, or no organizer show up, or no participant show up. Maybe now in times of online hackathons, there are additional risks. Bad communication, yes, very nice. So Rosa mentioned bad communication between all the volunteers and leaders that are organizers of hackathon. If you have some opinion on that, please, switch on your camera, switch on your microphone. Let's discuss a little bit online if you like. Ahmed, very nice. An individual thinking they can handle things, overconfident and self-assigned task without communicating to superior, hierarchy, experience. Yes, I've seen that several times. We don't follow through with what we said we'd provide. Desiree, yes, very nice. Good. So all kind of, I'm surprised that I haven't heard that basically internet fails. Yes, maybe with power cut you also don't have internet. Maybe you have, depends where you are. But maybe that only saves you for something like, maybe 1 or 2 hours until the batteries of the laptops go down. If you are lucky and in a situation where basically you have some of the IT on some reserve power. What's with coffee? I think for physics it would be the disaster. The coffee machine breaks during a hackathon. No energy drinks, no swag. No one submitted project, nice. Yes, we don't joke about no coffee. This is a nice comment. The caterer fails to show up. Perfect. So, any suggestions? If you like, basically, if you want to switch on your camera or your microphone and you want to take one of his examples and try to describe how you would try to handle the situation. Anybody interested? The coffee is a big one, I see. So somebody wants to address the coffee problem of a power outage, which is basically, in most cases, I guess, will also kill the coffee. Dealing with the event only on front end, the back end being the organizing team, yes. So there are many, many different of the scenarios, and you can imagine all kind of things. The important thing is that you play this through with your team, that you take maybe only half an hour, maybe an hour, and you think about the worst case things that can happen and how you try to mitigate them. How do you deal with them? How do you basically try to find a solution, make the best out of a situation? And this you can only do with a team. There's no hope that you can do that alone. And in the best case, you can do that by taking the entire knowledge of your team and listening to everybody. I see there's a nice comment about basically weather, fire, shooting, yes, all kind of environmental things that can happen. So there's a nice comment for the power outage. A good alternative would be to add more weight to soft skills in the competition, such as pitching your project. Yes, very nice idea. For in-person hackathons, that's perfectly fine. For online hackathons, I think you anyhow lost almost everything. So you have to think about scenarios. How can you maybe survive, half an hour, where basically you have no communication with your participants, and how can you make up after it. So how can you basically, after this half an hour or maybe 2 hours of not being able to communicate with your participants, how can you basically try to mitigate afterwards? So in CRM, typically you have 4 different factors that you think of when you do this kind of plannings. One thing's what you call software. So software is everything what basically is the regulations. So for example, for a hackathon, this would be your code of conduct, everything what you put on your website, everything what basically gives the structure and the rules that you operating a hackathon on. This you call in CRM, you call software. Then there's something that we call hardware. And hardware is, for pilot, this is basically, the aircraft with everything what belongs to it. For hackathon, the hardware, this is basically, everything what you need to operate. Starting from the venue, it's starting the coffee machine, maybe the power, internet. So everything what you basically need to run your hackathon. And then the other part that you need is so-called liveware. This is, all your colleagues, your volunteers, your participants, this is the interaction between all the people. And so you have to make sure that you basically think about scenarios and failing scenarios for all of this kind of 3 things. And then these 3 factors, software, hardware, and liveware are basically surrounded by environment and Jada basically also mentioned weather, fire, shooting, which are maybe some kind of environmental kind of aspects that you have to take into account. Good. Are there some other kind of ideas what you want to mention? Or some questions? I see Jonathan mentions attendee sponsors hack data gets lost, have multiple backups available and know by all involved. Yes, very good point. And you have a good idea for the power outage or internet outage? Nope. Good. So let me try to summarize a little bit. If you ever get into the need to crash a hackathon, my advice is try to crash it like an airplane. And in order to do so, you need to study CRM, crew resource management. You have to understand how to communicate to your team in the best possible ways. You have to understand what can go wrong with all this kind of communication, with the communication between the people, between the participants, and take some time. Take some time to think through the worst case scenarios and discuss with your team before what you could do to mitigate, how you could prepare yourself for those worst case scenarios. There's one last, maybe this we can still discuss a little bit. For internet issues, I always ask 4 to 6 members of a team to have pre-charged internet mobile providers. Yes, very good idea. A very good backup solution. It can also happen that when the entire internet crashes for whatever reason for 1 or 2 hours. So be prepared and have a slight plan what you do, how you then basically catch up with communication afterwards with your participants. So I'm pretty sure everything will go fine with your hackathons. It is, you never basically, in most cases, you can always recover from this. But it's really like, with pilots. Pilots train a lot for the worst case. And yes, it's much more that is basically on the play there. But just to give you a number, 1 in 100,000 pilots ever basically has to attempt a water landing. But still, we think it's a good idea to be prepared. The same thing what I try to tell you is it's also a good idea to prepare for, things going wrong on the hackathon. So take a little bit of time, not too much, maybe 1 hour, 2 hours is enough. and think about what can go wrong. And if you're of the opinion that you don't need that, if you think that, you know, you as a hackathon organizer, you can do it yourself, you don't need a team that you can rely on, you don't need a team that you basically have to hear what they have to propose, then my only advice is please make sure that at least you are
cognitively there, cognitively there, cognitively there, cognitively, that's amazing, cognitively there, cognitively there, cognitively there. Go back to that question. Person, woman, man, camera, TV. So they say person, woman, man, camera, TV. Could you repeat that? Person, woman, man, camera, TV. So I said, yeah. Person, woman, man, camera, TV. That's amazing.
Okay, so thank you everybody. Yes, Artyom, perfect, fine. I like your command. I hope you enjoyed it. If you have some questions, I'm around. You can always reach me also via Twitter or on Discord. Happy to discuss if you have other ideas, what can go wrong on a hackathon and how to mitigate. Thanks for your attention. If you are still interested to discuss something, please also come online, switch on your camera, or ask a question either here on Discord. Thanks a lot.